Evaluate exponential functions. So our objective is the same as the title. We're going to evaluate exponential functions. So first things first, what is an exponential function? Well, it is any function of the form f of x equals b to the x, where your b, which is your base, is greater than 0 but not equal to 1, and x, which is your exponent, is any real number. Okay, as I mentioned, the number b is called the base. In an exponential function, the exponent is the variable, like here. Examples include, I got 4 examples for you. How about f of x equals 2 to the x? And again, the number 2 here is the base. As a reminder, the base is positive, not 0, and the base can also not be equal to 1. Let's do g of x. Another example here. How about 10 to the x? So the base here is 10. How about h of x is equal to e to the x plus 1. E is called the natural base. E is the Euclid's number, 2.71828 or something like that. But the base here is e, and the exponent is x plus 1. So you have a variable in your exponent. And we'll do one more. How about j of x is equal to 1/2? So this is the base. As long as it's positive and not equal to 1, it can be a fraction. And we'll raise this to the x minus 1. So those are 4 examples of exponential functions. In general, we're going to use a calculator to evaluate exponential functions. It's fairly difficult to evaluate them otherwise, so we'll be using our calculator. Okay, I got 2 examples, and I'll do that with you. Use the calculator to answer these questions. The exponential function f of x is equal to 42.2 times 1.5x, times 1.566 to the x, models the average amount spent, which is the f of x, the amount spent in dollars, at the shopping mall after X hours. What is the average amount spent to the nearest dollar? Let's note that. After 4 hours. So X is equal to 4. Well, so f of 4 is equal to 42.2 times 1.56 raised to the 4th power, because x is 4. And this is just going to go into a calculator, and I'll do this with you. Let's see, 42.2, whoops, I messed that up, 42.2, open parenthesis, 1.56, close, raised to the, that's the caret button down here, raised to the 4th power, and to the nearest hour, it's 249.92. To the nearest hour, that would be, to the nearest dollar, not hour, dollar, this would be $250. So approximately $250. Okay, our second example. We have an exponential function. Again, exponential function has a variable in the exponent. Here's a variable in the exponent. Here's a variable in the exponent. The exponential function f of x equals 1144 times e raised to the 0.0325. Wow, that's a lot of digits. X. And we're told this models the gray wolf population of the Western Great Lakes, which is f of x, the population, X years after 1978. According to this model, or using this model, what was the gray wolf population rounded to the nearest whole number of the gray wolf population of the Western Great Lakes in 2018. Okay, so we know that 2018 minus 1978 tells us this is 40 years. So 2018 is 40 years after 1978, and that's what X stands for, the number of years after 1978. So our X is equal to 40. Okay, so F of 40 is going to equal 1144 times E to the 0.0325 times 40. And that goes into a calculator, and we're going to round it to the nearest whole number, the nearest wolf, in other words. And you should come out with 4,198 wolves in 2018. So that's exponential functions. Most important, the key thing to remember with an exponential function is right up here. An exponential function has the variable in the exponent. The variable will be in the exponent in an exponential function.